One of the biggest mysteries in all of technology right now is what is actually going on inside the mind of an AI. So today, we're going to dive into a pretty groundbreaking new way to visualize and understand how these incredibly complex systems reason their way to an answer. Okay, so let's get right into it. We ask an AI a question. It spits out an answer. Simple enough. But what's happening in between? What are the actual steps, the thoughts that lead it from point A to point B? That's the huge question we're tackling today. For years, that whole process has been a complete black box. We could see the input, we could see the output, but the journey from one to the other, it was totally hidden. Just a complex jumble of calculations that we had no real way of interpreting. And look, this black box thing isn't just some academic curiosity, it's a major hurdle. I mean, think about it. If we can't see how an AI gets to a conclusion, how can we ever really trust it? How do we debug it when it gets things wrong? Or, even more importantly, how do we make sure it's safe? The old way of doing things, just having a person read through an AI's text output to figure out what went wrong, is totally impractical. It just doesn't scale. It's slow, it can be really subjective, and it makes getting the bigger picture almost impossible. This has been a serious bottleneck for AI research for a long time. So, the big question is, how do we finally crack open that box? Well, a team of researchers has developed this absolutely brilliant new tool to do just that. It's called the Landscape of Thoughts, and it lets us, for the first time, visualize the entire reasoning journey from start to finish. To put it simply, Landscape of Thoughts, or LOT for short, is this really powerful visualization tool. It takes all of those complicated text-based reasoning steps an AI spits out and transforms them into an intuitive, easy-to-read 2D map. It's kind of amazing. And the process is actually elegantly simple. First, it captures all of the AI's step-by-step reasoning. Then it measures how close each one of those thoughts is leaning towards any of the possible answers. And finally, it plots that entire journey onto the 2D map. So here's the key to reading these maps. Just think of it like a weather map, but for an AI's brain. The blue areas show the correct reasoning paths, the red areas show the incorrect ones, and the darker the color, the more thoughts are concentrated in that one spot. It's a super simple key, right? But it is so powerful. Okay, now for the really exciting part. We've got the maps. So what do they actually tell us about how an AI thinks? Let's dig in and see what we can find. First up, let's see if we can spot a difference between a weaker AI model and one of the newer, state-of-the-art ones. I mean, does a stronger model actually think better? Well, these maps give us a pretty clear answer. Let's start with a smaller 1 billion parameter model. Take a look at this map. See how the blue areas, the correct thoughts, are kind of scattered and uncertain. The path is all spread out, slowly, inefficiently, wandering its way toward the right answer, which is that green star over there. Now, let's switch to a much, much more powerful 70 billion parameter model. Wow. Okay, the difference is just night and day. Look at this map. The blue path isn't scattered at all. It's this dense, focused, confident line heading straight for that green star right from the very beginning. You are literally seeing a more efficient thought process happen on screen. But this is where it gets almost uncannily human. These maps can actually reveal moments where the AI seems to pause and rethink its own work, almost like it's saying to itself, wait, let me check that again. And that is exactly what this map is showing us. It captures these moments of self-evaluation, you can see them marked there in yellow, and then self-correction, marked in green. We're watching the AI spot its own potential mistake and actively change its path. It's incredible. We're literally watching it think. So, obviously, this is way more than just a cool visualization. The real power here comes from using these incredible insights to actively make our AI systems better, safer, and a whole lot more reliable. And this leads to a pretty logical next question. If our own eyes can see the difference between a good, focused path and a bad, scattered one, could we train a program to do the exact same thing, but automatically? And the answer is a resounding yes. The researchers created what they call a verifier. It's a simple, pretty lightweight model that's been trained on all this map data. And its whole job, its entire purpose, is to watch an AI's reasoning path in real time and predict if it's on the right track or if it's heading for a dead end. And here's the crucial part. It actually works. By using this verifier to spot flawed reasoning early, you can prompt the AI for a better path, and it consistently boosts the overall accuracy. It's basically like giving the AI a helpful guide on its shoulder to keep it from getting lost, all without having to do any costly retraining.
All of this really points to a future where AI reasoning isn't this big mystery anymore. It gets at the bigger picture, the huge importance of building AI systems that are transparent, that are systems we can actually understand.
So what's the big takeaway here? Well, for the first time, we can make the invisible process of AI reasoning totally visible. We can objectively see the difference between good and bad thinking. We can then use those insights to actively make these systems better. And ultimately, that all leads to AI that we can finally begin to trust. And this isn't just some theoretical idea. As the researchers themselves put it in their paper, a tool like this has massive real-world benefits for engineers trying to build better models, for researchers trying to understand them, and especially for safety experts working to monitor and control them.
And that leaves us with one final, pretty provocative thought to chew on. We've just taken a massive leap towards being able to read an AI's mind. So the next logical question is, what happens when we can not only read it, but also guide it?